Every company says they're data-driven, but most of them are drowning in broken pipelines nobody wants to own. That's exactly the problem the AWS Certified Data Engineer certification is built to solve. It proves you can design, build, and optimize real data pipelines on AWS, not just talk about big data, but actually engineer it at scale. In this session, we're running through real exam-style practice questions covering ingestion, transformation, and governance. The stuff the AWS Certified Data Engineer exam actually tests. Let's get into it. Question no. A company is developing a product recommendation system that uses Amazon OpenSearch service. The system needs to perform key nearest neighbors, key, NN, vector searches on 10 million product embeddings with 768 dimensional vectors. The system must maintain high recall accuracy and support incremental updates without re-indexing as new products are added each day. The system must also accommodate complex filtering based on product categories and inventory status. Which vector index type will meet these requirements? A. Face Inverted File Index, IVF, with an nList value of 10, 24, and an nprobes value of 10. B. Lucene Hierarchical Navigable Small Worlds, HNSW, Index, with an M value of 16 and an F construction value of 200. C. Exact KNN Search, that uses a painless script scoring. D. FICE Index with binary quantization and an nList value of 4096. Correct answer? B. Lucene Hierarchical Navigable Small Worlds, HNSW, Index with an M value of 16 and an F construction value of 200. Explanation. The correct answer is B, because the scenario requires scalable, approximate vector search, high recall, incremental updates, and complex filtering. Amazon OpenSearch service supports KNN vector search for recommendation use cases, and OpenSearch supports KNN vector fields for high-dimensional vector search. The Lucene HNSW option is strongest here because OpenSearch documentation specifically states that Lucene supports KNN searches using HNSW graphs and supports Lucene filters for KNN searches. That directly matches the need for category and inventory filtering. Exact KNN with painless script scoring is accurate, but too slow for 10 million vectors. IVF can be efficient, but is less ideal for frequent incremental updates and complex filtering. Binary quantization reduces memory, but sacrifices accuracy. Question no. 2A Data Engineer manages a provisioned Amazon Redshift cluster that stores petabytes of data. The cluster receives continuous data ingestion from multiple sources. As data volume grows, the query performance has degraded. The current table design uses the auto distribution style and default sort keys. The data engineer needs to optimize the query performance for recent transactions. Which solution will meet these requirements? A. Offload historical data to Amazon S3. Use Amazon Redshift Spectrum to query the data directly. Retain frequently accessed data in Amazon Redshift. B. Decrease the number of nodes of the current node type in the Amazon Redshift cluster. C. Change the data distribution style of the Amazon Redshift tables to all for all the tables that contain historical data. Switch from columnar storage to row-based storage. Use Amazon Redshift ML for the complex queries. Correct answer. A. Offload historical data to Amazon S3. Use Amazon Redshift Spectrum to query the data directly. Retain frequently accessed data in Amazon Redshift. Explanation. The correct answer is A, because the workload has grown to petabyte scale, but the performance requirement is focused on recent transactions. The best architecture is to keep hot, frequently queried data inside Amazon Redshift and move historical, cold data to Amazon S3. Amazon Redshift Spectrum lets Redshift efficiently query structured and semi-structured files in S3 without loading that data into Redshift tables. And most of the data remains in S3 while Spectrum performs parallel processing. This reduces pressure on the provision cluster while preserving query access to historical data. Decreasing nodes would worsen performance. Distyle all for historical tables can increase storage and maintenance overhead. Redshift is already columnar, so switching to row-based storage is not valid. Question no. 3A data engineer needs to build a data pipeline to process medical records from 50 hospitals. The pipeline must ingest 5 gigabytes of data from each hospital and remove personally identifiable information, PII. The pipeline must then transform the data and save the data in a central store. The pipeline must automatically retry after transient failures without manual intervention. Which solution will meet these requirements with the least operational overhead? A. Store the data in Amazon S3. Use AWS Glue extract, transform, and load ETL jobs to process the data. Use AWS Glue Data Brew to remove the PII. Orchestrate the pipeline by using AWS step functions. B. Deploy an Amazon EC2 instance to run a custom Python script to orchestrate the pipeline and remove the PII. Store the data in Amazon RDS. Use AWS Batch to process the data. C. Store the data in Amazon S3. Create an AWS Lambda function to process the data and mask the PII. Configure Amazon Event Bridge to orchestrate the pipeline. D. Orchestrate the pipeline by using AWS Batch to remove the PII and transform the data. Store the data in Amazon S3. Correct answer. A. Store the data in Amazon S3. Use AWS Glue extract, transform, and load ETL jobs to process the data. Use AWS Glue Data Brew to remove the PII. Orchestrate the pipeline by using AWS step functions. Explanation. The correct answer is A, because the pipeline requires scalable ingestion, PII removal, ETL transformation, centralized storage, and automatic retry handling. Amazon S3 is the correct landing and central storage layer for large hospital data files. AWS Glue ETL is appropriate for managed data transformation at this scale, and AWS Glue Data Brew is the best fit among the options for low-code data preparation and PII handling. Step functions is the correct orchestration service because it supports retry policies for task states, parallel states, and map states without manual intervention. EC2 custom scripts and AWS Batch add more operational work. Lambda is not suitable for 5 gigabytes per hospital with heavier transformation steps. Therefore, S3, Glue, Data Brew, and step functions is the least operational overhead design. Question no. 4. A company has a data warehouse in Amazon Redshift. The Amazon Redshift provision cluster is created in a VPC. The company is developing a new application in AWS Lambda that needs to access the data from Amazon Redshift. The company's security policy states that AWS services can access the Amazon Redshift cluster only from the AWS network. Traffic between Lambda and the Amazon Redshift Data API must remain in the AWS network. Which solution will meet these requirements? A. Use the Data API in the Lambda function to access the data. Set up an Amazon VPC endpoint for the Data API. B. Use the Data API in the Lambda function to access the data. Set up an Amazon VPC endpoint for the Lambda function. C. Connect to the Amazon Redshift cluster from the Lambda function by using an Amazon Redshift ODBC driver. Set up an Amazon VPC endpoint for the Lambda function. D. Connect to the Amazon Redshift cluster from the Lambda function by using an Amazon Redshift JDBC driver. Set up an Amazon VPC endpoint for the Lambda function. Correct answer. A. Use the Data API in the Lambda function to access the data. Set up an Amazon VPC endpoint for the Data API. Explanation. The correct answer is A, because the requirement specifically says that traffic between Lambda and the Amazon Redshift Data API must remain on the AWS network. AWS documentation states that you can call the Redshift Data API with Amazon VPC endpoints, and that this keeps traffic between applications in the VPC and the Data API in the AWS network without public IP addresses. The Data API also removes the need to manage database drivers, persistent connections, and network configuration from Lambda. Creating a VPC endpoint for Lambda is not how Lambda privately reaches Redshift Data API. ODBC and JDBC drivers introduce connection management and do not address the stated Data API traffic requirement. Therefore, Data API plus the Redshift Data API VPC endpoint is correct. Question No. 5. A data engineer uses the AWS Glue data catalog to manage data lake metadata. The data engineer's extract, transform, and load (ETL) process creates new partitions in an Amazon S3 data lake throughout the day. The new partitions are not queryable through Amazon Athena until an AWS Glue crawler run finishes each night. The data engineer needs to make new partitions immediately available for querying. Which solution will meet these requirements? A. Modify the ETL process to use the AWS Glue create partition API call after creating each new partition in Amazon S3. B. Configure S3 event notifications to invoke an AWS Lambda function that copies new partition data to a separate cataloged S3 bucket. C. Use Amazon DynamoDB streams to track partition changes and update the AWS Glue data catalog. D. Use the AWS Glue Start Import Labels Task Run API call to synchronize partitions on demand. Correct answer. A. Modify the ETL process to use the AWS Glue Create Partition API call after creating each new partition in Amazon S3. Explanation. The correct answer is A, because Athena can query new partitions only after the partitions exist in the AWS Glue data catalog. Waiting for a nightly crawler creates unnecessary delay. The direct fix is to update the data catalog as part of the ETL process by calling the AWS Glue Create Partition API immediately after each new S3 partition is written. AWS Glue documentation states that Create Partition creates a new partition and requires the database name, table name, and partition input structure. Copying data to another bucket does not register partitions. DynamoDB streams is unrelated unless the partition lifecycle is already stored in DynamoDB. Start Import Labels Task Run is not the API for partition registration. The correct operational pattern is event, write partition, then immediately register metadata. Data engineers who can actually ship reliable pipelines are some of the hardest people to hire right now. Passing the AWS Certified Data Engineer certification proves you can. Ingest and transform streaming and batch data at scale. Design data models and manage full data lifecycles. Apply governance, security, and data quality best practices. Optimize pipelines for cost and performance, not just function. Don't walk in relying on general AWS knowledge. This exam goes deep on data-specific services. CertBoosters practice questions are mapped to the real exam domains. Kinesis, Glue, Redshift, Lake Formation, all of it. Links in the description. Go prove you can turn raw data into something a business can actually use.